Hi all, welcome to new class. Today's class is the problems related to DC motors. Let us go through the problems. A 500 volt shunt motor has 8 poles with a wave wound armature having 1208 conductors. The flux per pole is 1 into 10 raised to minus 2 webers. If the armature and field resistance are 1 ohm and 250 ohm respectively, find the speed at which it would run when taking a current of 40 amperes from the mains. So first of all, draw the diagram of shunt motor. So this is the diagram of a shunt motor and the given data are 500 volt. That means the voltage supply voltage is 500 voltage. Then 8 poles, that is P is equal to 8. Then wave wound. So the number of parallel path is equal to 2. Then having 1208 conductors, so Z is given as 1208. Then flux per pole, that is phi is 1 into 10 raised to minus 2 webers. Then armature and field resistance. Armature resistance is Ra is equal to 1 ohm and field resistance means here this is shunt field. So RSH is 250 ohm. Then find the speed at which it would run. So N we have to find when taking a current of 40 amperes from the mains. So IL is given as 40 amperes. So here we have to find the speed. For that we know the relationship between EB and N, that is EB is equal to phi ZNP divided by 60 into A, but the back EMF we have to find first. So for that this is a shunt motor, so EB back EMF is V minus IARA. So first of all we have to find IA. To find IA we have to know about this ISH. Only IL is given. So first of all we have to find this ISH. So for that we know the relationship between V, ISH and RSH, that is ISH is equal to V divided by RSH, that is 500 divided by 250 and that is equal to 2 amperes. Now we can find IA, that is IA is equal to IL minus ISH. IL is 40 minus ISH is 2 and that is equal to 38 amperes. Now we can find EB. That is EB is equal to V minus IARA, that is 500 minus IA is 38 into RA is 1 and we get 462 volts. Now we can apply this EB to this equation and we can find the speed. So EB is 462. So in this equation 462 is equal to phi is 1 into 10 raised to minus 2 into Z 1208 into N into P is 8 divided by 60 into 2. From here we get N is equal to 462 into 60 into 2 divided by 10 raised to minus 2 into 1208 into 8 and we get it as 573.67. So we can round it to 574 RPM. So this is the speed. Next question is, the armature circuit resistance of a 18.65 kilowatt 250 volt series motor is 0.1 ohm. The brush voltage drop is 3 volt and the series field resistance is 0.05 ohm. When the motor takes 80 amperes, speed is 600 rpm. Calculate the speed when the current taken is 100 amperes. So this is a series motor. So first of all, draw the diagram of series motor and note down the given datas. So this is the diagram of a series motor and these are the datas given. RA is 0.1 ohm, the voltage is 250 volt, then brush voltage drop is given as 3 volt, then the series resistance is 0.05 ohm, and when Ia is equal to 80 amperes, speed is given as 600 rpm, and when Ia is equal to 100 amperes, the speed we have to find. So we know the relationship between speed and EB. So speed is equal, EB is equal to 5ZNP divided by 60 into A. And here we can write EB is proportional to 5 into N. So here first of all we have to find this EB, that is back EMF. So for the first case, EB1 is equal to, here this is series motor, so we can write V minus Ia into RA plus RSC, then minus brush drop. So here in the first case 250 minus Ia is, when Ia is equal to 80 amperes, that is this is Ia1 and this is Ia2. So let this be N1 and N2 we have to find. So here this is 80 into RA is 0.1, then plus RC is 0.05 minus 3, and we get it as 235 volts. Next we have to find EB2, that is when Ia is equal to 100 amperes. So we get 250 minus 100 into 0.1 plus 0.05 minus 3, and we get it as 232 volts. So here we got EB1 and EB2. Now we have, from this equation we can write EB2 divided by EB1 is equal to phi2 divided by phi1 into N2 divided by N1. And we have to find N2. So we can write N2 divided by N1 is equal to EB2 divided by EB1 into phi1 by phi2. But in the case of series motors, phi, that is the flux, is proportional to the armature current Ia. So we can write phi1 divided by phi2 is proportional to or equal to phi1 divided by phi2, we can write equal to Ia1 divided by Ia2. So here we can write this as EB2 divided by EB1 into Ia1 divided by Ia2. So we can write N2 is equal to EB2 divided by EB1 into Ia1 divided by Ia2 into N1, and that is equal to EB2 is 232 divided by 235 into Ia1 is 80 divided by 100 into N1 is 600. and we get N2 as 473.87, and we can round it as 474 RPM. So N2 is 474 RPM. So that is about the problems related to the DC motors. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.